Class AB power amplifiers combine Class A and Class B to achieve an amplifiers with more efficiency than Class A but with lower distortion than Class B. The Q point is located between the midpoint and cutoff, and also it above Class B but below the Class A. And lastly, the amplifier's two output transistors conduct somewhere between 180 degree and 360 degree of the input waveform. This is the formula that we use to calculate input power, output power, and also maximum efficiency.
This is the design of the simulation. The software that we have used is FILAS website. You can search this website on the browser to stimulate the circuit. In the process of the simulation for every power amplifier circuit, we have used all these parameters to design the new circuit. We need to remove the original circuit in the website and draw the new circuit. Change all the parameters that used such as resistor, load, AC source, and others. To view the waveform, you can right-click at the component and choose View in New Scope. Lastly, record all the waveform and analyze it. This is the FILAS table. FILAS table is a short form for facts, ideas, learning outcomes, action, and solution. The structure table is helpful to overcome problem solution technique. So, we need to identify the design solution based on our FILAS table. I will explain to you about two examples of the uses of this table. As we can see, the first fact is about the Class AB power amplifier can be designed as a CD player system with a speaker. So, we set the idea that this simulation can be designed by using the software BSpice, Proteus, or FASTAC. However, the learning issue will be how to design a CD player system with a speaker as the load for Class AB power amplifier. We need to take an action to understand the circuit and study about the circuit first. Finally, we set the solution by checking the circuit. The second fact is the calculation about power distribution and efficiency. The ideas for this issue will be calculated using Class AB power amplifier formula. Now, the learning issue will be how to calculate power dissipated, useful power being delivered to the load, and efficiency. We need to take an action to search information through the notes and website about the calculation circuit and the problem. Then, for the better solution, checking the circuit and the calculation with your lecturer.
The circuit consists of 3 resistors, 2 diodes, 2 BJT which is NPN and PNP, 3 supply which is 1 AC supply and 2 DC supply. The AC supply is for Vin and the DC supply is for VCC and VEE. The waveform in Vin show a sinusoidal waveform with Vp or Vmax equal to 7 volt. Waveform Vout also show sinusoidal waveform with Vp or Vmax equal to 7 volt. For Iout, the waveform also show a sinusoidal waveform with Ip or Imax equal to 1.152 ampere. The VCE versus IC graph for Q1 shows the following characteristic. Where the VCE versus IC graph for Q2 show the following characteristic.
I will explain about analysis. As for summary, we can conclude that our calculation and simulation is almost the same value. The power supplied to the circuit for calculation and simulation is 6.687 watt and 6.597 watt has 1.34% of error. while the output power developed across the load for calculation and simulation is 4.083 watt and 3.981 volt has 2.5% of error. Next, it has 1.18% of error for the circuit efficiency for calculation and simulation, that is 61.06% and 60.34%. Then it has 0.047% of error for the maximum input power for calculation and simulation, that is 8.59 watt and 8.594 watt. The maximum output power for calculation and simulation is 6.7 watt, has 0 error. Next, the errors of the maximum efficiency for calculation and simulation is 78.58% and 78.54%, has 0.05% of error. Last but not least, the error of power dissipated for calculation and simulation is 1.85 watt and 1.844 watt, is 0.35% of error. To improve the error is by adding diode at the base, since diodes share the same work principle at base emitter junction.